Hello everyone, I am Jay Santosh. So today we are going to discuss about research paper based on deep learning. So the topic of this research paper is a survey on deep learning based resource allocation schemes. So the authors of this research paper are Dong Yong Kim, Hei Jun Jung, In Ho Lee. Introduction of deep learning in resource allocation. Overview. Increasing complexity in wireless networks requires efficient resource allocation schemes. Deep learning is being leveraged to reduce computational complexity and improve performances. Challenges. Traditional iterative algorithms suffer from high complexity and inefficiency in large scale networks. Deep learning techniques provide adaptive, scalable solutions to these issues. Motivation. Complex data. Wireless networks generate massive amounts of data. Scalability. Deep learning models can handle complex and high dimensional data. Optimization learns optimal solutions, reducing the need for high complexity computations. Applications voice and image recognition, language processing, and resource allocation. Categories of deep learning based resource allocation. So, there are briefly three types of resource allocation technologies or methods being followed. One, supervised learning. Second one is reinforcement learning and unsupervised learning. In supervised learning, uses labeled data to predict optimal resource allocation. Example, power allocation in vehicular networks using backscatter. Reinforcement learning interacts with the environment to learn optimal actions. Example, UAV base station deployment using deep Q networks, DQN. Unsupervised learning, no labeled data required, effective in dynamic systems. Example, channel allocation in device to device networks. Supervised learning in a resource allocation. How it works. Train sound labeled data to approximate optimal solutions. Reduces the complexity of conventional algorithms. Example, power allocation in multi-carrier non-orthogonal multi-access systems achieves similar performance to optimal solutions with lower complexity. Reinforcement learning in resource allocation. So we're going to take a look about how reinforcement learning in resource allocation takes place. So the basic roadmap of how it works is it learns to take optimal actions based on environmental feedback. Can be applied to systems with multiple diverse objectives. Example, DQN based resource allocation in UAV assisted sensor networks optimizes energy efficient service for ground users. Unsupervised learning in resource allocation. How it works. Learns patterns from data without labeled supervision. Ideal for time varying systems where labeled data may be not available. Example, unsupervised learning for channel and power allocation in device to device communication, effective in handling dynamically. Limitations of deep learning in resource allocation. Supervised learning requires large amount of unlabeled data which can be hard to generate. Reinforcement learning. Training by trial and error can occur high computational overhead. Unsupervised learning may not achieve optimal results compared to supervised approaches. Hybrid learning approaches. Hybrid models combining the strength of deep learning methods to address limitations. Example, integrating supervised learning with a reinforcement learning to leverage labeled data and adaptive decision making. Future directions. Explore combinational of these learning types to optimize resource allocation schemes. Challenges in practical implementation. Static network structures. Many deep learning models are designed with static structures, making them less adaptable to dynamic networks. Solution. Graph neural networks are proposed to use networks with variable input or output sizes, dynamically adjusting to different network environments. Dealing with imperfect channel state information. Problem. Wireless systems rarely have perfect channel state information due to estimation errors. Solution. Deep learning can mitigate performance degradation caused by imperfect CSI by learning to adapt to uncertain channel conditions. Future trends and research challenges. Emerging trends. Heterogeneous learning. Combining various learning models to optimize resource allocation. Graph-based learning. Using GNNs to better capture network topology and dynamic changes. Challenges. Ensuring low latency and energy efficient models in real world application. Incorporating robust learning methods for uncertain environments. Conclusion. So we're going to discuss about the basic the basic summary of this presentation. Deep learning offers promising solutions for efficient resource allocation in wireless networks. Supervised or reinforcement and unsupervised learning each provide distinct benefits, and hybrid approaches are the way forward. Future research, further exploration of hybrid learning models addressing real-world deployment challenges like network dynamics and CSI estimation errors. These are the references. Thank you.